Hi everyone. Today we are going to see about order of a reaction. So order of a reaction, already we have seen three methods are there to find out the order of a reaction. So we have seen about how to plot a graph of reaction rate against concentration of the reactant and how we can find out the order of a reaction by using that. And now we are going to see to identify the order of a reaction we are using a concentration of the reactant against time taken. So concentration of the reactant versus time taken. So if you see those graphs, here for zero order reaction, a graph is a descending straight line, right? So the rate of a reaction is the slope of the graph. So here if you see zero order, first order and second order reactions are given, but how will you distinguish between these orders? So here the first and second order reactions, for example, sorry, the curve is the graph is a curve, right? So you can see the first order a curve and the second order a deep curve, right? So the curve for the second order reaction is much deeper than the first order reaction. So this shows, you can distinguish the two curves by you seeing these two curves. You can find out the first order and the second order reaction. So only thing you need values. So by values, if you make a graph, if you plot a graph, you will get to know which is zero order, which is first order and second order. So according to that, you can you can find out the order of the reaction. But we can also distinguish between the two curves by determining successive half-lives. Okay, so if you see half-lives, for example, over here, here T half 1 and T half 2, this gives you zero order reaction. The straight line shows, the straight slope shows it's a zero order, and the curved one shows it's a first order reaction. And if you see the deep curve one shows second order. So how to calculate the T half value? So if you see this, the concentration of cyclopropane versus the time taken, the rate of a reaction. So here I have given the topic half-life and reaction rate. So the reaction rate is this, concentration by time taken is rate reaction, right? So reaction rate versus half-life. So by how to calculate the half-life? So by using the concentration and the reaction, the time taken, you are plotting the graph like this. But if you see, if you take 2 moles of, if the concentration is 2, then the half value, if you take half, is 2 to 1, right? So 2 to 1 is half. But if you take 4, but the reaction starts from 4, the concentration here 4 moles per decimeter cube. So from 4 to 2 is 1 half. So 1 half you are getting over here. So the time taken for that is 17, right? 17 minutes. And if you take the second second T half, 2 to 1 is second T half, right? So what is half-life actually? The time taken for the concentration of the reactant to fall to half of its original value, right? So 4 to 2 is half of 4. So 2 to 1 is a half of 2, and 1 to 0.5 is a half of 1. So like that, if you see the T half values, so you can see over here to reach when it reaches 1, the concentration 1, it takes time till 34.3 actually. So if you subtract 34.3 minus 17, you will get 17.3. So 17.3 is the next T half, the second T half, if you see. And the third T half is 34.3 to 51 it takes for 0.5, right? So when it reaches over here, it is 51. So when you see the T half value, it is 16.7. So 16.17, 17.3 and 16.7. If you see the T half 1 and T half 2, T half 3 value. So what you need to do over here? So you need to see the mean value. So 17 plus 17.3 plus 16.7 by 3. So you will get 17 minutes. So the mean half value, the mean half life is 17 minutes. Okay. So the first order, the reaction is first order. This shows the reaction is first order. Why? Because the successive half lives are more or less constant. So 17, nearly it is 17 only. So in a first order reaction like this, the half life is independent of the original concentration of the reactant. Clear? So this is why this is how we are calculating the order of a reaction by using the half lives. Okay, thank you. Bye bye. We'll see you with the next nice topic. Bye bye.